The 3D rocket printer is the biggest metal 3D printer in the world. It was made by Relativity Space, a new company that wants to print a whole rocket in just 60 days, including the fuel tanks and rocket engines. There are good reasons to make a rocket with 3D printing. In this video, we reveal the genius of 3D printed rockets. Stay with us to the end of this educational tour and have your mind saturated with facts about rocket printing. Let's get started. There are 4 main parts to a rocket: payload, direction, structure, and movement. The propulsion system, made up of the fuel tanks and the rocket engines, makes up most of the rocket. Cryogenic fuel and oxidizer are pumped into the combustion chamber through an injector, where they react and release tremendous heat. This makes the exhaust gases more prominent, leaving the rocket nozzle at high speed. The more thrust that can be made, the faster this exit speed and the faster the mass flow rate. So rockets are enormous, complicated engineering projects that have, up until now, mostly been made using old methods. That means you must build the rocket's tools before creating it. For example, before they could build NASA's next big rocket, the Space Launch System, SLS, they had to make the Vertical Assembly Center, VAC. This tool is 170 feet tall and is used to join the rings, barrels, and domes of the rocket's fuel tanks together. They built it like a rocket, and before they could start building it, they had to make all these custom tooling designs and ensure they worked. After over a decade of work, they finally had one being put together on the pad. The company Relativity Space has only been around for 5.5 years, and this year they plan to launch their first rocket. For over a decade, aerospace companies have used 3D printing to make small, complicated parts. This is simply amazing. While building a rocket the traditional way could take up to 9 to 10 months of sheer hard work, 3D printing takes only 2 weeks. Take the injector as an example. That is the most important part of any rocket engine. The liquid propellant must be turned into a fine mist that mixes quickly, and these have been moved to 3D printing all over the business world. One of the best things about 3D printing is that it makes rockets with fewer parts. Have you ever thought about how hot it gets inside the chamber where a rocket burns? As high as 3,500 Kelvin. That's so hot that almost any metal would melt. So how come the chamber where the rocket burns and the end of the rocket to not melt? The answer is that the cryogenic propellants are passed over them to cool them down. It is hot enough to boil iron within the space shuttle's main engines. Interestingly, you can freeze objects outside the device since liquid hydrogen is passed through them. However, to create those, you would need to take a large number of incredibly tiny pipes, mold them into the shape of the combustion chamber and the nozzle, and then braze weld them together. And it certainly would be an absurdly time-consuming task. The combustion chamber and the nozzle would be made up of more than 1,000 separate pipes that would need to be welded together. So you can 3D print things rather than go through the bother. For example, when you print a 3D rocket nozzle, the channels for the cryogenic propellants will be printed right into the single part, so you don't have to add 1,000 pipes to the outside. Most of the time, metal powder and lasers are used to 3D print the smaller parts of the nozzle. One of the questions usually asked is, since the 3D metals are not strong, how can they work? Actually, printed materials are more durable than those constructed manually. Since the corporation creates its unique alloys in-house, it is paradoxical. As a result, a complete material science team is devoted to creating new alloys just for 3D printing. Because the material melts, cools, and solidifies so quickly, one may use this physics concept to create extremely strong alloys. Another big advantage of 3D printing is that it lets you make changes quickly. You can make a part quickly, test it, quickly change it, and print it again. The 3D printing method could change the look of a rocket in a big way, which might be its biggest effect. Engineers can use 3D printing to make parts that would be hard or impossible to make with more traditional methods. Designs that look like living things are just as easy to print as regular structures. The complete transformation of a rocket's appearance may be the effect of 3D printing that is most significant. Engineers can create things using 3D printing that would be difficult or impossible to make using conventional methods. Designs that are supple, curved, and bio-inspired are just as simple to print as regular structures. Most people are unaware of the conventional rocket construction process. And many people think that since it involves rockets, it ought to be highly developed and filled with robots. However, that is actually untrue. Interestingly, automation has not been used at all in aerospace. A commercial plane is made up of millions of different parts. It would be very different for robots to assemble several million parts, as they would easily do with tens of thousands of parts in an automobile. It's a much tougher issue. So this is how 3D printing automates the aerospace industry. Instead of putting all the parts together with robots like you would with a car, you put them together in the 3D file, and then the printer prints them already put together. That's it, guys, on the genius of 3D printed rockets. What do you think? Do you think these engineers are onto something massive? Will you be excited to travel with these 3D printed rockets if the fares are slashed by 100? Let us know your thoughts and observations in the comment section below. If this video is insightful for you, then go on and like this video. Please kindly subscribe to our channel and click on the bell button for more of our updates.